So let's practice finding the inverse of a function algebraically. Let's ignore my phone ringing here at home as well. Sorry about that. So first thing I think we should do before we even determine if or find out what the inverse is I think we should check to make sure it even has one. So we had 3x, was it minus 2 quantity cubed plus 7, right? So here's this function, right? After we look, I'm zooming in and out just to make sure that I'm not missing any pieces of it. But once we have the graph, remember that we always test with the horizontal line test to determine if something is 1-to-1, and if it's 1-to-1, it has an inverse. Okay, the only part I'm skeptic about is this part right here. And you can see, like, well, it kind of looks like it's flat. Like, I don't know, if I drew a horizontal line here, I think I might hit it twice. You won't. It just doesn't increase. Uh-oh, where'd it go? It just increases extremely slowly. It's never actually flat. Okay, so even though it looks like maybe it wouldn't pass the horizontal line test, these cubic functions do pass the horizontal line test, and they are 1-to-1. Okay, so coming back to it. So I know it has an inverse, and how do I find it, right? We talk about replacing f of x with y to start, right? Again, that's more of a bookkeeping step to make this next step make sense, in which we switch the x and the y's. So anywhere we see an x, we put a y, and we put an x wherever the y was on the other side. Now from here, okay, we're solving for y. When we're doing any inverse operations, we always go in the opposite order. So, like, you know that the order of operations is, please excuse my dear Aunt Sally, right? PEMDAS. When we're solving, we go in the opposite order, right? We do what's inside the parentheses last. We take care of this exponent second to last. We do any multiplication or division only after we've taken care of any addition or subtraction, any floating constants. So the first thing I'm going to do is I'm going to subtract 7 from both sides. And we have to be content with the idea that I can't actually subtract 7 from x. I just have to leave it. Okay, now we have this product. We have 3 times y minus 2 cubed. We're not actually going to do this cubing. Okay, remember, we're just looking to get rid of that exponent. Okay, but we can't get rid of the exponent until we get rid of the multiplication here. So we divide both sides by 3. Divide by 3. We get x minus 7 over 3 is equal to, we still need these parentheses because this quantity is being cubed, right? So now what operations do we have left to get rid of? Something that's inside the parentheses and something that is an exponent, right? So the exponent, we have to get rid of that next. How do we get rid of a cube? We get rid of a cube by doing the cubed root, right? Just like we get rid of a square by doing the square root. So I have to take the cube root of the right side, and I have to take the cube root of the left side, which means everything that's on the left goes underneath a cubed radical, like so. Okay, so now we have the cubed root of this mess, x minus 7 over 3. We didn't say it was going to be clean, right? We just have to get this variable by itself. We got rid of this 3 by taking the cubed root. Now all we have is y minus 2. So we're going to add 2, and we're going to add 2 to this. Now, we can't add something that's not under a radical to something that is. So this is going to look horrible, okay? But the final form of this inverse function looks like so, right? The plus 2 has to be completely outside of that radical, and here is our inverse function. Now, as a quick last check, let's take a look at our operations here. What do we have? We have addition, we have subtraction, we have division, and we have a cube root. Okay, we have the addition of 2. What did we have in the original function? We had subtraction with 2. We have subtraction of 7. Up here we had addition with 7. Down here we have dividing by 3. In the original function we had multiplying by 3. And we have a cubed root. In the original function I was cubing something. So all of these operations that were in the original function, I have their inverse operations down here in the inverse function. It's important to check that when you're done.